All right, everybody, get ready for this one because we're really diving deep today into, well, something that seems like it's straight out of science fiction.
Mm.
We're talking about using giant space bubbles
Oh, wow.
to combat climate change.
Yeah.
It's pretty wild, right?
It does sound pretty wild when you just say it like that.
Yeah.
Yeah.
But, you guys send us those articles from Science Alert and Devine Magazine
Right.
and Lit World, and they're exploring just that.
They are.
So is it just a lot of hot air?
Well, it's definitely attention grabbing.
Yeah.
But there's some real science behind it.
Okay, so what is it?
Yeah.
What are we even talking about when we say space bubbles?
So imagine like a giant raft just floating out in space.
Okay.
And it's
How giant are we talking?
we're talking like the size of Brazil.
Oh, wow.
Yeah, massive, massive. And it's not just one big sheet or anything. It'd be made of all these interconnected inflatable bubbles. And these bubbles would be made from this super thin reflective material.
Okay.
We're talking thinner than a soap bubble,
Wow.
but it would have to be strong enough to withstand, like the harsh conditions of space.
Right, of course.
And so the idea is that we'd strategically position this gigantic sunshade basically in space
Okay.
to deflect a portion of sunlight away from Earth.
So just like giving the Earth a little bit of shade.
Basically, yeah, like a giant umbrella for the Earth.
Okay, I can get behind that, but space is huge.
Right.
It's like, how are we going to make sure these things actually stay in the right spot?
So that's where the L1 Lagrangian point comes in. It's this like sweet spot between the Earth and the sun where the gravitational forces kind of balance out. It's like a little gravitational parking spot
Oh, okay.
for the bubble raft. So it stays put and we
Okay.
don't need to make these constant adjustments.
So it's like a cosmic parking brake.
Exactly. Yeah.
That makes a lot of sense. But still, this whole thing is incredibly ambitious. Like, how feasible is it really?
So it's definitely early stages.
Okay.
But some researchers at MIT,
Okay.
at their Sensible City lab, they're doing some really interesting work on this.
Okay.
And they've actually already had some success with inflating these thin film bubbles in conditions that they're creating that mimic the environment of space.
Whoa, so this isn't just like theoretical, like they've actually inflated these things.
They've inflated them, yeah.
Wow.
Yeah. And one of their big things was finding the material
Okay.
that could actually do this.
Right.
That could reflect enough sunlight while also being lightweight enough to launch.
Right, because if it's too heavy, it's not going anywhere.
Exactly.
Yeah.
And it's got to be durable.
Oh, yeah, of course. You
Yeah.
got space debris and all that stuff.
Right, you got all the radiation. So
Right.
that was a major hurdle for them.
Yeah.
Finding something that's both reflective and tough enough.
Okay, so they've got this bubble material kind of figured out.
Yeah.
But then comes the small task of, building a Brazil-sized sunshade in space.
Exactly.
That's going to
Yeah.
be a whole other level of complication.
That's a whole other beast.
Yeah.
We're talking about manufacturing and assembling something of this scale in space. It's a huge challenge.
Yeah,
And on top of that, even getting the materials up there,
that's what I was thinking.
it's a lot.
Because, how do you even get that much stuff into space?
And the articles mentioned something about like magnetic accelerators, like giant railguns.
Railguns to
Yeah.
launch the material.
Yeah, like giant cannons, basically.
Basically.
Shooting stuff into space.
Is that even realistic?
That's one of the ideas they're exploring. The technology is still being developed, but it could be a lot cheaper and more efficient than rockets.
Right, because rockets, that's a lot of fuel.
Exactly. A lot of fuel.
Yeah.
A lot of waste.
So this railgun thing could be the way to go.
Potentially.
Okay.
Yeah.
So, okay, let's say we somehow figure out this whole space construction thing and we get these bubbles up there. Like, what happens next?
That's a good question.
They're downsides.
Yeah. Are there any unintended consequences that we should be thinking about?
Right, because it's not like a perfect system, right?
Right. And that's kind of what makes this whole idea so controversial.
Okay.
Yeah. We're talking about messing with like the entire planet's climate system
Right.
in a really big way.
So less sunlight, that means what?
Wow.
Like, what kind of impacts are we talking about?
I mean, the most obvious one is what happens to global temperatures,
Right.
which is, kind of the goal.
Right, yeah.
But like even if we can just turn down the sun a little bit, who knows what that's going to do?
Right.
It could change weather patterns. Like what if it messes with the ocean currents?
Right.
Plants might even be affected.
Yeah, it's a lot.
Yeah. And it's hard to say exactly how things might change.
And it's not like we can just dial it back, right?
Exactly. Yeah.
If it doesn't work, it's not like, oh, take down the space bubbles.
Right. It's not that easy.
We're talking about like a structure the size of Brazil floating in space.
It's a huge deal, and it would be really hard to reverse,
Okay.
Like way harder than something like,
Okay.
like stratospheric aerosol injection, where they literally just like pump particles into the atmosphere.
Okay.
We're talking about something that's a lot harder to undo.
So it's more like buying time.
Yeah, that's a good way to put it.
Not like a fix-it-all.
Right.
That
And that
kind.
leads into another big concern people have about geoengineering in general.
Okay.
This idea of moral hazard.
Moral hazard.
Yeah, it's like if we start relying on these big technological fixes,
Okay.
are we going to stop trying to fix the actual problem,
We're
reducing emissions? Like,
Yeah.
that's the root cause here.
Right.
We can't just keep polluting and be like, oh, the space bubbles will take care of it.
So it's like putting off going to the doctor
Right.
because you've got a cough,
Yeah,
but you're like, yeah, they're working on a new cough drop.
exactly. And it might not even work.
Okay, yeah, that's a good point.
So we got to focus on the real solutions here.
And even if, like, we get these space bubbles and it works perfectly,
Yeah.
are we just going to want to do more geoengineering projects?
That's right. Where do we draw the line?
Like, it could get kind of scary, right?
It's a slippery slope. Yeah.
Yeah.
That's the ethical dilemma with all this.
It really is a slippery slope when you think about it.
It is.
Because
Yep.
who gets to make these decisions?
Right.
Like, if we're talking about something as big as literally putting a shade, like a structure in space,
Yeah.
the size of Brazil, to block out the sun,
Yeah.
that's not just like one country's decision, right?
Right. No, not at all. And that's another like really complicated thing about this whole thing.
Okay.
The geopolitical stuff.
Okay.
Like right now, there are no rules, There's no like international agreement about like how to handle these big geoengineering projects.
So, like, who even decides if we do it?
Exactly. And then even if we did decide, like who's in charge if something goes wrong?
It's a mess.
Yeah, it's a big can of worms.
And it's more than just countries, right?
Right.
What about, like, indigenous communities?
Yeah, absolutely.
Have a different perspective, right?
Totally, yeah. Like a lot of indigenous communities, they have this totally different view of,
Yeah.
our relationship with nature.
Yeah,
And we have to include them in these discussions too.
totally.
If we're going to do this, it has to be like a worldwide conversation.
Yeah.
We need scientists. We need policymakers. We need ethicists.
Right.
And like you said, we need those communities that would be most affected by it.
It just seems like, I don't know, every time we talk about this, it seems like we're getting
Yeah.
into
Yeah.
like murkier and murkier waters,
It's complicated. Yeah.
It is.
It's not simple.
So with all of this,
Yeah.
with all these risks, all this like ethical stuff,
Yeah.
why are we even considering something as wild as launching a giant space bubble into orbit?
Well, I think it really just shows you how big this problem is.
Okay.
Like climate change, it's the biggest thing we're facing.
Right.
And we kind of have to look at every option, even the really crazy sounding ones.
Okay, so it's not necessarily that scientists think this is like
Right.
the best idea. It's just that
It's an idea.
they're looking for anything, right?
We're running out of time,
Yeah.
so we got to look at everything.
That's scary.
It's a little scary, yeah, but it's also kind of inspiring, right? Like
Right.
we have to figure this out, and it's going to take a lot of creativity and a lot of cooperation.
So I guess if our listeners take away one thing
Yeah.
from this whole conversation about space bubbles,
Yeah.
what would it be?
I'd say, the fact that we're even having this discussion, it shows how smart people are,
Yeah.
that we're even thinking about stuff like this.
Right.
But it shows how serious this is.
Yeah.
We need to do something.
We can't ignore it.
We can't just hope it goes away. We got to do something.
And it's on all of us, right?
It is, yeah.
It's not just, oh, the scientists will fix it or whatever.
It's not just on them.
We all got to do our part.
Reduce our emissions, support good policies,
Yeah.
and just, like you said, do our part.
So yeah, if you're listening to this,
Mhm.
think about what can you do? How can you make a difference?
Exactly. We're all in this together.
All right, everybody, thanks for joining us for another deep dive.
Yeah, thanks for listening.
We'll catch you next time.